So at long last, we're getting close to the top of the stack of the Android layer cake. And what we're going to do today is talk about common services and apps. And we'll start by talking about this concept of object-oriented frameworks. So to make sense out of the other discussion we're about to have about Android's frameworks layer, it's helpful to understand what a framework is. So we've talked a little bit about this, and I'll go into a bit more detail now. So we'll talk about what a framework is, and I'll give you some examples in Java and Android. Some of these things you've worked with, some of these things you're going to be working with. And why is this important? You literally cannot write an app in Android that isn't using frameworks, right? There's no possible way to do that. I think there really is no possible way to do that. So what's a framework? I've given you a little overview. This is going to go a little deeper than we've talked about before. A framework is basically an integrated set of components that collaborate to provide a reusable architecture for a family of related applications. So that's kind of a mouthful. What does that mean? It means we've got a bunch of components or classes, typically. And you certainly know we have lots of classes, right? We've got all the classes from the Java platform that come along for the ride, copied by Google. We've got the classes from the Android platform, which are developed. We talked about that last time. Lots of those things. And they're integrated. These things don't just appear onesie-twosie in isolation. They actually work together. And they provide a reusable architecture. We've talked about architectures. We've talked about things like services and activities and broadcast receivers and intent handlers and so on, for a family of related applications. And you'll see that when you're building Android apps, there's often a lot of things that are common. In fact, much of that commonality is pushed into the frameworks we're about to talk about. So you don't have to reinvent things from scratch. Here's a simple example that we'll talk briefly about, and we'll look at more next semester dealing with Android concurrency frameworks. There are three primary characteristics of frameworks. And by the way, these are great final exam questions. The first characteristic is inversion of control, or IOC, by callbacks. So what is inversion of control? I always think of this as inversion of control. The framework controls the main execution thread or threads. In the case of Android, it's the thread, the user interface thread. And then the framework decides how and when to run application code. What are the circumstances under which this code will be run? And we'll see lots of examples of that very shortly. I think I've mentioned this before. Inversion of control is often called the Hollywood principle, which actually, ironically, over the course of the semester is not as funny as it used to be, right? All of a sudden, Hollywood isn't this great, wonderful thing. It's a cesspool of perversity and depravity, right? You know, so, but there actually is something relevant here, right? So what is the Hollywood principle? The Hollywood principle says, don't call us, we'll call you, right? Which again takes on a whole new perverse set of meanings now. But back when John Vlasides coined this term 20-some years ago, it was actually funny and charming. But it's about callbacks. You get called back to do stuff. So here's an example. In Android, you have this thing called the looper, and it runs in the user interface thread, and you can also have them in other threads. And it basically dispatches callbacks on handlers which call back to runnables. So it's a callback-based mechanism. And everything in Android's user interface world is driven by these callbacks. The runnable that's dispatched by inversion of control doesn't really know or care how or why it's called back. It just knows it was called back. And so, as we'll see in a second, it's your job typically to implement that callback, and it's the framework's job to figure out how and when to call it back. The second thing that a framework provides is so-called integrated domain-specific structure and functionality. What the heck does that mean? Well, you have to understand that in the context of earlier reuse paradigms, such as class libraries. And in a typical or conventional class library-based approach, the classes are domain-independent, right? What's a domain-independent class? A string, right? You can use a string anywhere. An integer, you can use an integer anywhere. It's not really specific to any particular domain other than the domain of writing software, which is a very big sort of meta-domain. So domain-specific in this context means, for example, the domain of financial services, or the domain of real-time avionics control, or the domain of patient-centered healthcare, or whatever. And sometimes domains are very application-focused. Sometimes domains are more sort of technology infrastructure-focused, such as the domain of concurrency frameworks for Android smartphones. And these capabilities are grouping the classes together in such a way that they help to fulfill systematic reuse in one or more domains. So in this case, I'm just focusing on the domain of concurrent Android programs. Not surprisingly, many of Android's frameworks focus on mobile stuff, since it's meant for mobile systems. So this is used to enhance systematic reuse because you're getting a lot more bang for your buck. A string class, an integer class, those are widely reusable, but they also cover a postage stamp sized piece of the design space. You very rarely fail to meet your customer requirements because your string class didn't have enough methods in it, right? It's almost always another way to work around that. But if you've got a great class to be able to do financial services or healthcare or shoot down a missile or whatever you need to do that's domain specific, you can get the job done way, way faster than you could have if you had to write it yourself. So here, these things like messages, message queues, future tasks, executors, handlers, loopers, runnables, etc., they're all part of the domain-specific portion of Android concurrency, and Android provides these frameworks like the Hammer framework and the async task framework built out of these components that know how to work together in various ways. And then the third piece of a framework is it provides a so-called semi-complete application. And what that means is you just have to plug in your code and you can leverage all the stuff that comes off the shelf. And the way that that works in frameworks is by things called hook methods. And a hook method is basically a means of being able to plug application logic into the framework. Very specifically in the context of Android and Java, hook methods are usually, though not always, going to be implemented as virtual methods. So you'll have a virtual method. And what these do is they mediate interactions between common abstract classes and variant concrete classes. I'll talk more about that in a second. So hook methods implement patterns that customize the framework components, like the template method pattern or the strategy pattern, which are patterns you've studied before. And what you typically do is you'll have base interfaces or super classes with virtual methods or pure virtual methods, abstract methods as they call them in Java. Those are common. And then subclasses come along and override and fill those things in. And I'll give you plenty of examples, although you can probably think of some off the top of your head. Java Runnable is a great example. It's an abstract interface that provides the basis for concrete variants, right? You fill in the run method, either by subclassing or by lambdas or so on. All right, so that's a quick overview of what a framework is in the abstract. Let's talk about some examples of frameworks in Java and Android. There's lots and lots of them. So the activity framework, Android's activity framework, is used to control the user interface's interaction with the user from the main thread of control. And as you can see, it's got all kinds of lifecycle methods here, like onCreate, onStart, and so on. And these methods are dispatched automatically by the framework when events occur that the application has registered interest in. So when the activity is first created, there's a callback. When an activity is started, stopped, destroyed, there are callback methods that get invoked. Here's another example. You can have these listeners, which are used to handle button clicks. So you can say, here's a button. I've got myself a button somehow. And I can set its click listener. And then when someone clicks it, then the click listener's onClick hook method will get called back. And I think you can use lambda expressions to make this even more concise, but back in the day, you had to kind of write it like this. So when you click a button, then the onClick method on the click listener gets called back. So that's a classic example of callback-driven code in the Android activity framework. Java also has lots and lots and lots of frameworks. We've been talking primarily about concurrency, so we'll focus on that. So in this environment, you might have something like the Java thread, where you've got a runnable, and you say start, and then the run hook method gets called back on either the thread or on the runnable. So you can control that. You don't have to write the threading logic. You don't have to write the implementation of thread. You just have to figure out what to do when a thread is started. There's also something else called the executor service. We've talked a tiny bit about it here. That's what's used under the hood for things like the completable futures. Remember, you could pass in an executor, give a thread pool where your actions would run if you had multi-cores and so on. So that's something called the executor service. And under the hood, that has a bunch of methods like the call hook method of a callable that gets dispatched in some thread in the thread pool to do their thing. So that's another example of threads. Pretty much everything you've written here used frameworks, right? So we used the completable futures, we used parallel streams, we used the fork join pool. Those are all other examples of frameworks that we've used in this class. All right, so under the hood, frameworks use Java's inheritance and polymorphism features. We've talked about those a little bit. Hopefully you're familiar with that from before. You could look at our Java for Android MOOC if you need to catch up on this, but I think everybody knows what polymorphism and inheritance are. So here's an example where you have an abstract class or an interface with a virtual method or an abstract method, and then you can come along and customize it to fill in what it does. And that's an anonymous instance of an anonymous inner class. That's so, 2014, and this is the way you do it now with Lambda expressions, much cleaner. Okay, so that's just a quick overview of the concept of an object-oriented framework, going a little bit deeper than we had talked about previously.